A very good morning and welcome all of you to today's lecture. Dear students, in our previous lecture of B.Sc Part 3 of Paper 3 Physical Chemistry, we have taken the unit first as elementary quantum mechanics and so many names actually has been named by that is of classical wave mechanics, quantum mechanics, and we have also expressed about its necessarily conceptual terminology including blackbody radiations, ideal blackbody radiations, its various scientific law depending upon and to define blackbody radiation and ideal blackbody radiation. We have also expressed in our previous lecture that we assume any system this container as a rigid blackbody when we provide to the heat to this that is of a rigid dynamic system. The part which absorbs is known as absorptivity and the blackbody radiations and its that is of a rigid system having a tendency absorption as well as that is of emission, which is symbolized by that is of E. I meant to say the device which we have selected as an imaginary, the absorption should do that is of emission, that is such black body imaginary rigid body is known as that is of black body radiation. If absorptivity lambda is equals to that is of emission, so it will be classified, it will be termed as that is of ideal blackbody radiation. Further, in the series of various contents of elementary quantum mechanics, various scientific law, we have also derived in our previous lecture. Once again, I defined in that is of compact form. Once again, I repeat it. In order to define, let us proceed various scientific law in which the blackbody radiation is based here. Lumiere-Prexing's law. Any rigid, hard, spherical body when is heating at a normal temperature, firstly to take the form of that is of red. After at infinite heating, it will take the forms of white color due to the presence of visible light. Similarly, various scientific law in the series of various scientific law, we also expressed about Kirchhoff's law, Wien's displacement law, Rayleigh's law, Planck's radiation law, and we have also derived about the concept about Bohr atomic theory, which is applicable for that is of monoatomic species here, where it postulates angular momentum will be directly is equal to that is integer multiple h upon 2 pi, and its drawback of Bohr's atomic model, that the Bohr atomic limitations and drawback of Bohr atomic models who defined that electrons is moving that is of around this levels, these energy levels one can name as that is of K shell, L shell, M shell, N shell, and while electron which is moving around the nuclei neither can emit nor absorb the heat. Also, the emission, if electrons provide the heat, electron which jump from lower energy level to the higher energy level and come back into its ground state by the emission of energy of that is of photon and is expressed by that is of del H nu. In respect of drawback of Bohr's atomic theory, we have also delivered our lecture, the single lines which observed by Bohr actually by applying the scientific instruments, equipments, it has been optically, photochemically, it has been proved that the single lines which were observed by Bohr's atomic model by means of that is of electric field or magnetic field, strong electric field, the splitting of these single thick lines into parallel that is closer, that is of thinner lines. These effects was known as that is of star effect, and that is of Zeeman effect here. Similarly, in the series of various contents of this topic, quantum mechanics, we have also defined about that is of de Broglie hypothesis. In de Broglie hypothesis, when electron is moving around the nuclei, its behavior just like particle as well as that is of wave, that is of its property here. Particle property to have associated with that is of Planck equation, and wave property to have the associated with that is of Einstein equation. I mean, de Broglie hypothesis can be derived by that is of two important equation, that is that is of Planck equation and that is of Einstein equation. P is equals to that is of h upon lambda. After keeping Planck as a constant, in our previous lecture we have defined the momentum is inversely proportional to that is of wavelength which is incident upon the species, atomic species here. The theoretical experimental made by Davison and Germer of de Broglie's hypothesis. Similarly, in the series of various topics in our previous lecture, we have also defined about uncertainty principle. Uncertainty principle say it is impossible to find out the exact position, and that is of a momentum of a electron or a particle which is moving around the nuclei. We want to find out the value of position that increases in just direction, in just position. The same situation, the uncertainty of momentum, that is of a degree. I mean to say the multiplication of del x and that is of del p will be equal to that is of h upon 4 pi, or that is of h cross here. Further, we have also delivered in the classroom, dear students, about the property of psi, physical significance of psi and psi square, and important postulate of that is of quantum mechanics. The next topic I will deliver here on that is a particle in one dimensional box. I mean to say that is of potential well here, and in potential well here we have to derive the value of psi x is equals to plus minus root 2 upon a sin n pi a upon that is of x. In order to define about particle in one dimensional box, it will be derived the value of that is of here by considering here first one, that is of here in absence of electric field. What is the modification of Schrodinger wave equation? This particle is known as free particles. Case second, that is in presence of electrical field. In presence of what will be the position of electric modification of Schrodinger wave equation. Let us discuss this by this one by one. Case first, and that is of case second. First one, that is of Schrodinger wave equation, is expressed case first, delta square x divisible by delta x square delta y square plus delta y square delta z square plus 8 pi square m upon h square into a minus v psi is equals to 0. First case we are going to derive here. Now we will derive the case second, that is in presence of electric field. I mean modification of Schrodinger wave equation tomorrow. Thank you, and thank you very much.